Hello, this is Andrea Hendricks. The object of this video is to show you how to graph the inverse sine function, find the domain and range of that function, as well as evaluate the inverse sine function. Before we can talk about the inverse sine function, we need to look back at the graph of sine. So I have for you a graph of sine over two periods from negative 2 pi to 2 pi. Well, if you heard me in the opening video, we talked about how the fact that inverses only exist when we have functions that are one-to-one. Well, one-to-one functions have to pass a horizontal line test, meaning if we draw any horizontal line through the graph of the function, it can only hit one point in the graph. Well, you see our horizontal line through the graph of this one hits more than one point on the graph. In fact, it would hit infinitely many because remember the graph of sine is periodic and its domain is from negative infinity to infinity. So it continues forever and ever and ever. So this is not a one-to-one function. But we can solve that problem by restricting the domain of the sine function to a part of the graph that covers all of the y values for sine. Well, so let's just kind of go back and review this. We know that the domain is negative infinity to infinity. The range is from negative 1 to 1. So we want to make sure that we restrict our domain to a piece that has in its range negative 1 to 1. Well, just looking at the graph here, if I wanted to choose from 0 to pi, I have a problem there because I only have in that piece of my domain values for y that go from 0 to 1. So I cannot include my restriction to be from 0 to pi. Nor can I include from 0 to 3 pi over 2 because that restriction is not 1 to 1. So I have to choose a piece of the graph that is 1 to 1 and also goes from negative 1 to 1. Well, the standard way that we do that, let me show you on the next page, is here. We restrict the graph of sine to be from negative pi over 2 to pi over 2. So the domain of the restricted graph, I'm going to put a d sub r. Domain of the restricted graph is from negative pi over 2 to pi over 2. Now our range is still negative 1 to 1. So now we have a one-to-one piece of the graph of sine that has all of the range values there. So now we can think about this as being our original function f of x is the restricted sine and from that we can get the graph of f inverse of x. And so f inverse of x is going to be sine inverse of x. Now please do not confuse this notation. We've seen that before dealing with sine when we talked about the reciprocal of sine is cosecant, but that was written, let me just write it here and I'll erase it. That was when we had sine x all raised to the negative 1. That means to do 1 over sine x. Okay, but if we have it written like this, sine negative 1 of x, that's really the inverse sine of x. Okay, so that does not mean to do the reciprocal at all. So another way that we can actually write the inverse sine notation is we can call it arc sine of x. So those both mean the inverse sine. Well, the way that we get the graph, if we know the graph of the original function, to get the graph of the inverse function, we interchange the ordered pairs. So in other words, this pi over 2, 1 would become 1 pi over 2. Pi over 2, square root of 2 over 2, sorry, I said pi over 2, didn't I? Pi over 4, square root of 2 over 2 would become square root of 2 over 2 pi over 4. So we're just interchanging the x and the y. 0, 0 would still stay 0, 0 on the graph of the inverse function. negative pi over 6, negative 1/2 would become negative 1/2, negative pi over 6. Negative pi over 2, negative 1 would become negative 1, negative pi over 2. And then another thing about the graph of a function and its inverse, if we graph those on the same coordinate system, those two graphs have to be symmetric with respect to the line y equals x. So if you flip them over the line y equals x, you would get a mirror image of itself. So that's why this curvature, if you will, changes directions. Okay? The concavity of that changes. Now, keep in mind what the function sine does and what the function sine inverse does. For our function f of x equals sine x, our input in that function is what? It is an angle, and typically in radians. I mean, we can have the calculator mode be in degrees, and we can talk about that, but typically it's in radians. So an angle is in radians, and our output is the trig value, right? Well, for the inverse function, our input is a trig value, and our output is an angle. But there's some restrictions that we have to keep in mind. For these things to exist, the angle that we're either inputting into the function for sine, or the angle that we're getting out of sine inverse, has to be between negative pi over 2 and pi over 2. So in other words, it has to be an angle that's in quadrant 1 or quadrant 4 that is between negative pi over 2 and pi over 2. So our output also has to be between negative pi over 2 and pi over 2. Now, the trig function, when we figure that out and find the sine of it, our output value is between negative 1 and 1, right? Well, that means the input into the sine inverse has to be between negative 1 and 1. It does not make sense to have an input into the sine inverse function to be outside of the negative 1 to 1. Okay? So another thing that we can state here, if you will, we can say this, that if we know that y is equal to the sine inverse of x, that is true if and only if sine of y is equal to x. So you're really asking yourself this question. If you want to evaluate y is equal to sine inverse of x, you're saying what angle has a sine of x? Okay, and in particular, what angle between negative pi over 2 and pi over 2 has a sine of x? If you can answer that question, then you can evaluate the sine inverse expressions. So let's talk about that now. And you may want to have your unit circle with you. Again, that unit circle really needs to be kind of getting into your brain so that you don't have to rely on it so much. I know if you're initially looking at this, it might be overwhelming, but keep practicing those values, at least so that you can reconstruct that if you need to. So when we're looking at sine inverse of x, and in this particular one we want to evaluate sine inverse of 1. Sine inverse of 1 means this. We need to think about what angle between negative pi over 2 and pi over 2 has a sine equal to 1. Well, we know that sine is equal to 1 at pi over 2. So that would tell us that sine inverse of 1 is pi over 2. And the way to check is take sine of pi over 2 and you should get 1. What about the inverse sine of 0? So we're thinking here, what angle has a sine of 0. And that is 0. Now let me back up for just a minute. Sine inverse of 1 being pi over 2, well look, we know the point 1 pi over 2 is on our graph, so that confirms our answer there because the input into the inverse sine was 1, the output is pi over 2. What about arc sine? Again, that's another way to write the inverse sine function. Arc sine of square root of 2 over 2 means this. What angle between negative pi over 2 and pi over 2 has a sine value of the square root of 2 over 2? And that is pi over 4. Okay. You could also use your calculator, and I'll show you that in just a minute. What about arc sine of negative 1/2? So we're thinking about this. What angle between negative pi over 2 and pi over 2 has a sine value of negative 1/2? Well, we know the answer cannot be an angle between 0 and pi over 2 because those are in the first quadrant. Sine is positive in the first quadrant, so it has to be an angle, a negative angle that is in the fourth quadrant. Well, to have a sine of negative 1/2, that's going to be what angle? Right, negative pi over 6. And that one happens to be on the graph that I have illustrated right here. What about arc sine of negative square root of 3 over 2? So again, I'm looking for an angle. That's going to have to be in the fourth quadrant because the sine value is a negative square root of 3 over 2. Well, that's going to be negative pi over 3. And lastly, what about sine inverse of pi? This is kind of a trick question because here I would be thinking about what angle has a sine of pi? Well, there is no such angle because pi is what? 3.14, so this is outside the domain, so this is not defined. Now if I wanted to find the sine of pi, I could certainly do that, but the sine inverse of pi does not exist. Now let me finish up with the calculator discussion. So if you wanted to graph the inverse sine on your calculator, you're going to need to do second sine x, okay, because you want to get the symbol that has sine inverse into your equation editor. Okay, do not do sine x all raised to the negative 1. That's not the same. So we need to have that built-in inverse function there. Now my window I set to be from negative 2 to 2 for my x values. Remember, because the domain of inverse sine is from negative 1 to 1. And so you can kind of see that here. My y min I set to be negative pi to pi. And I believe I did pi over 4 for my y scale. Okay. And so we have pi over 4, 2 pi over 4, which is pi over 2 here, and a negative pi over 2. So that confirms the points that we know, which were 1 pi over 2 and negative 1 negative pi over 2. And then if you wanted to enter and find sine inverse of the square root of 3 over 2, you again need to make sure your calculator is in radian mode. Well, that will give you your answer in terms of radians. If you wanted to get an answer in terms of degrees, you could put degree mode. So sine inverse of the square root of 3 over 2, and I get 1.047. Well, to confirm that, you could check that pi over 3 is 1.047, and it is, so that tells us that the sine inverse of the square root of 3 over 2 is really pi over 3. Now if I input sine inverse of 4, notice that you will get an error message, and that is because 4 is outside of the domain of the inverse sine, because the inverse sine has a domain between negative 1 and 1. So if you have any questions, please don't hesitate to contact me. I'm going to do a video now for inverse cosine and inverse tangent as well.